Hello all, in this lesson we're going to be studying solutions just in general, but we'll give some definitions to some things that are important for the unit, like solvents and solutes, and we'll involve some tests, even logical tests that you can apply for solutions. The bookwork associated with this lesson, it looks really short, 1 through 4 and 6 on page 120. And the aim, so copy that down, and then right under that, copy down the aim. What is the solution and how do we identify them? That is the first aim in this unit. And then the essential question is, how are the properties of mixtures and solutions observed through concentration, saturation, and physical change? So we're going to need to answer that by the end of the unit, and I want you to start your own essential question organizer starting now. So it should be a third piece of paper for today's lesson that has the essential question listed, and also you'll begin a list of aims for Unit 8, which you'll keep track of and will go in your binder check. Okay, so copy down these particular do now questions. Don't answer them yet. We'll do those in class. All right, so particle distribution and solutions. Here's a particle diagram. This is showing a mixture because we have two different substances, these greens and these blacks, and they are mixed together and they're unbonded, and that's how I know it's a mixture. So a mixture is an unbonded mixture of elements or substances. Okay, so watch the following video to see what happens when I make each of the following mixtures. That would be copper 2 sulfate, copper filings in water, food coloring in water, and sand in water. Okay, so right here on the left is the copper 2 sulfate in water. It seems to have, some of it has dissolved, but the copper filings, it looks like none of it dissolved, and the sands didn't really dissolve. But it does look like the food coloring was able to dissolve. So the only mixtures above that are true solutions are going to be the ones that did dissolve. So I'm seeing that's true for the copper 2 sulfate. I'm seeing it's true for the food coloring in water. So I'll write that in now. Now going further, which of the mixtures along the right-hand side of the page are true solutions? Let's circle our choices below. So this one right here, it would be impossible to tell if it's a true solution because this is a particle diagram and it's too close up to tell if they're just mixed or if it's dissolved. However, when you look at brass is a mixture of copper and zinc, and you can tell that it has a really uniform mixture, so we're going to say that this is a solution. I think that one throws people for a loop sometimes because they expect solutions to only be for a solid dissolved in a liquid, but you should open your definition up a bit further and know that a solution is anything that is a homogeneous mixture, and I think you can tell by looking at the brass in this instance that it's a homogeneous mixture. It's not, you can't see that there's more copper on one side and more zinc on the other. Additionally, I think that we can call air a true solution because it contains several different gases inside it. It has nitrogen gas, oxygen gas, carbon dioxide gas, helium gas, water vapor gas, and that's just to name a few. So all of those together are very evenly mixed, so the air is also going to be a true solution. So brass and air. However, pizza is not a true solution. It is a mixture, but you can see that the mushrooms are separated from the pepperoni, and which is separated from the olives, so that means that it's not a true solution. It is a solution to hunger, though. Okay, solvents and solutes. The two main parts of any solution are solvent and solute. So typically we say that the solvent is the thing that does the dissolving and the solute is the part that is dissolved. But how do we really define which component does the dissolving and which one is dissolved? In areas where it could be confusing, Like let's say that you had a drop of alcohol in a bucket of water. The only way that you could tell which one is really dissolving the other is based on amounts. So the hard and fast definition is that the substance that occurs in the smaller amount is the solute, and the substance that occurs in the larger amount is the solvent. All right, so there are some ways to test whether or not a mixture is actually a solution, and the easiest way to do it is to shine a beam of light through it. So what do you think would happen to light passing through a true solution? It would pass straight through the solution without being redirected and bounced off. So for instance, in this image, I lit a lighter, which you can see right here, behind this solution, just to show that you can see that the light is coming through the solution and into the camera. So that's proof that this one is definitely a solution. Similarly, I put the lighter behind this one in this case, so you can see that the light is coming straight through, so we know that this one is also a true solution. However, this one and this one, which are kind of obviously not solutions, are not going to be able to pass light through the solute. So I summarized those results here. I said that for the copper 2 sulfate, which was the turquoise one, light passed through, and for the food coloring, which was the green one, light also passed through. So how do all true solutions appear to the naked eye? That would be clear because they're passing light through them. All right, now separating solvents from solutes requires certain equipment, and then there are other techniques that you may not use. So what you should remember here is that true solutions are clear, and a beam of light that passes through them cannot be seen. So we can infer that the size and distribution of the particles is very even, and the particles are very small. So if we were to let a true solution, stand undisturbed for a long time, it would not settle out. It would stay dissolved. And that's one of the ways you can tell a true solution from just a mixture. So on a related note, a filter would not work if you were going to try to separate a solvent and a solute, because filters cannot work on homogeneous mixtures, and true solutions are homogeneous. So the best separation method for solvents and solutes, if they are dissolved, is going to be most likely just distillation. Distillation can separate based on boiling point. Okay guys, you reached the pair up, so copy down these questions for your pair up, and then finally on the summary, copy down these questions for your summary. Thanks for watching.